Hey, I'm the wannabe coder, and welcome back to my channel. This is episode 2, and in this video, we're going to start shaping our Icy Tower style platformer by drawing the walls and platforms. We'll use the Turtle Graphics module to render the side walls of the tower, add a few starting platforms, and keep everything clean and organized by moving the drawing code into its own file. By the end of this episode, you'll have a fully rendered tower base on the screen, ready for the gameplay to begin. But first, a quick recap of where we're at. In the previous episode, we set up the game window, built a game loop to handle real-time updates, and tied everything together with a main function, all structured neatly using separate files for constants and core logic. Now we're ready to start drawing the actual tower elements. Alright, let's start by updating our constants.py file. Go ahead and open it up. We're going to add some new parameters to define the size and layout of the walls, platforms, and player. Now, scroll down to the last parameter we have in the file. Right below that, let's start by writing wall_pixel_size equals 30. This sets the wall size in pixels, and we'll use it to define the size of the shape later on. Turtle has a built-in method called shapeSize, which we'll use to scale shapes based on the values we define here. That method can take up to 3 numbers. The first one controls the height, the second controls the width, and the third controls the outline thickness. The first 2 are scale factors, based on Turtle's default shape size, which is 20 by 20 pixels. So for example, if we write shape size with 2 inside parentheses, Turtle treats that as 40 pixels tall and 40 pixels wide. But if we write shape size with 1 and 2 inside parentheses, that means the height is 20 pixels and the width is 40 pixels, because the first number sets the height and the second sets the width. The third value, the outline, is a bit different. It's measured directly in pixels, not as a scale factor. And if we leave it out, Turtle simply uses the default, which is a 1 pixel outline. That's why we define our size values in pixels first, and then divide by 20 to convert them into the scale factors that Turtle expects. Let's go ahead and write wall_shape_size equals wall_pixel_size divided by 20. This gives us the correct value we'll use to set the wall's width when we draw it. Now let's set the wall height. We write wall_shape_height equals screen_height divided by 20. Since our screen is 1000 pixels tall, this will size the wall shape so it fills the full height of the tower. And here's something really important to keep in mind. All of our collision logic in this game is based on the actual shape size, not just how things look on screen. So when we replace these shapes with custom images later on, those images need to match the same size. Otherwise, the collisions won't behave correctly. That's why we're setting up this structure now, to make sure everything stays consistent and reliable as we build. Now let's move on to the platform parameters. Right below the wall values, we write plat_pixel_size equals 30. This sets the height of each platform in pixels. It's the thickness of the rectangle we'll use to draw each platform. Next, we convert that value into a shape scale. We write plat_shape_size equals plat_pixel_size divided by 20. This gives us the scale factor for Turtle's shape size method, just like we did for the wall earlier. Now let's figure out how wide the floor needs to be, which is basically the distance between the 2 side walls. We write floor_pixel_length equals screen_width minus 2 times open parenthesis. Wall_pixel_size plus screen_margin close parenthesis. This subtracts the size of both walls plus a bit of extra margin on each side from the full screen width, so the platform fits neatly between the left and right sides of the tower. Now, let's convert that to a scale factor. We write floor_shape_length equals floor_pixel_length divided by 20. That gives us the correct horizontal size we'll pass into the shape size method. And finally, let's define the Y position of the ground platform. so we know where to draw the first one. We write ground underscore y equals minus screen underscore height divided by 2 plus 50. This places the bottom platform slightly above the bottom edge of the screen. Remember, in Turtle's coordinate system, the point 0, 0 is right at the center of the screen, so negative y values move downward and positive values move upward. Now for the last parameter in this section, the player. We write player underscore pixel underscore size equals 40. This sets the player's size in pixels. Even though we haven't added the player to the game yet, we need this value now because we'll use it to decide how far apart the platforms should be. When we start placing platforms on the screen, we'll want to make sure the distance between each one is realistic, so the player can actually jump from one to the next. That's why defining the player size early helps us make smarter layout decisions later on. Alright, now that we've finished updating the constants file, let's go back to the project folder. We're going to create a new file, call it renderer.py. This file will handle all the rendering in our game, except for the player itself. So things like the walls, the platforms, the score display, and game messages, all of that will go here. Keeping all the drawing logic in one place helps keep the rest of our code clean and easy to follow. Let's open it up and start building it step by step. At the top of the file, you'll notice I've already added a docstring. This is just a short summary that says the file handles things like drawing platforms, showing the score, and other visual effects. Next, we import the modules we'll need. We start with import turtle, so we can use turtle graphics to draw everything. And then we write from constants import asterisk. This brings in all the constants we defined earlier, like the screen width, wall sizes, platform sizes, and so on. Alright, now we're ready to start writing our first class. In Python, a class is like a blueprint for creating objects. It lets us group together data and behavior that belong to a specific thing. For example, if we want to draw platforms, walls, or score displays, each of those can be its own class with its own properties and methods. That way, we keep things organized and reusable, and the logic for drawing each part of the game stays in one clean place. Alright, let's write our first class. We write class general pen open parenthesis turtle.turtle close parenthesis and a colon. Make sure to note, turtle here has a capital T because we're referring to the actual turtle class from the turtle module. This means our class inherits everything from the turtle class and will be used as a blueprint for the other classes we create later. That way, we don't need to repeat this same setup in every single class. Inheriting from Turtle is a fancy way of saying, we're building on top of what Turtle already knows how to do. We don't have to rewrite everything from scratch. We just add or change the parts we need. Inside the class, we define the constructor. This is a special function that runs automatically when we create a new object from the class. It's where we set up anything the object needs right from the start. Before we write it, let's explain something important. Inside a class, self is just a way to refer to the object we're working with. It lets the class talk about itself, like my position, my speed, or my shape. Now let's write the constructor. We write def double underscore init double underscore with self inside parentheses, followed by a colon. Then we call the constructor of the class we inherited from. We do that with super with empty parentheses, dot double underscore init double underscore with empty parentheses. This line tells Python, run the turtle class setup code first, so we get all the turtle functionality. Then continue with our custom setup. Here's why that matters. We only call the constructor of the parent class when we're using inheritance. That means if our class is built on top of another class, like how our general pen class inherits from the turtle class, then we need to call the parent's constructor using super. This ensures that all the setup from the original class runs first, before we add our own custom settings. If we weren't inheriting from anything, there would be no parent constructor to call. so we could just skip this step entirely. Now we customize it. We write self.speed with 0 inside parentheses. This sets the animation speed to the fastest possible. It doesn't affect how fast things move. It just removes the little drawing animation Turtle usually shows. You can think of it like disabling the frame-by-frame effect, similar to using Tracer for faster rendering. Next, we write self.penup with empty parentheses. This lifts the pen so it doesn't draw lines when the turtle moves around. And finally, self.hideTurtle with empty parentheses. This hides the turtle shape so it won't appear on the screen. This gives us a clean, invisible turtle that we'll use as the base for all our other renderers. Now let's move on to the next class, the wall. We write class wall, open parenthesis, general pen, close parenthesis followed by a colon. This means the wall class is using our general pen as a starting point, so it already has all the setup we defined earlier. And since general pen is already a turtle, that means wall is a turtle too. Then we define the constructor. Def double underscore init double underscore open parenthesis self comma x close parenthesis followed by a colon. This constructor takes one parameter, x. That's the horizontal position where we want to place the wall, either on the left side or the right side of the screen. And later, when we create this wall object, we'll need to pass it that x value, so the constructor knows exactly where to place it on screen. Inside the constructor, we start by calling super empty parentheses dot double underscore init double underscore empty parentheses. This runs the setup from the general pen class. Then we write self.showTurtle with empty parentheses. This makes the turtle visible, since general pen hides it by default. Here, we override that. Next, we set the shape. Self.shape, open parenthesis, square, in quotes, close parenthesis. This gives our turtle a square shape, which will stretch to look like a tall wall. We do that with self.shapesize, open parenthesis, wall underscore shape underscore height times 100, comma, wall underscore shape underscore size, close parenthesis. Here, we multiply wall shape height by 100, because when the screen scrolls down later as we climb, the wall will still remain visible on screen. In fact, later on, we'll move these wall turtles into the background image, so we really just care about their X position for collision detection. Then we set the width using wall shape size. Just as a reminder, the first number is height and the second is width. After that, we set the outline color with self.penColor, open parenthesis, white in quotes, close parenthesis, and the fill color with self.fillColor, open parenthesis, slate gray in quotes, close parenthesis. Of course, you can choose any color you like. And finally, self.goTo, open parenthesis, x, comma, 0, close parenthesis. This moves the wall to its correct X position, either on the far left or far right, with Y set to 0, which places it at the vertical center of the screen. And that's it. We've now got a simple wall class that draws a tall colored rectangle and marks the side boundaries of the screen, both visually and for collision detection. Now let's move on to the next class, the platform. We write class platform, open parenthesis, general pen, close parenthesis, followed by a colon. That means this class is based on general pen. So again, it inherits all the setup we created earlier. Then we define the constructor. Def double underscore init double underscore, open parenthesis, self, comma, plat underscore x, comma, plat underscore y, comma, length, close parenthesis, followed by a colon. This constructor takes three parameters, plat underscore x. This is the horizontal position where the platform will be placed. Plat underscore y. This is the vertical position, how high up the platform appears. Length. This determines how wide the platform will be. We'll choose this value randomly from a certain range because we want platforms of different sizes, not all identical in length. Inside the constructor, again, we start with super, empty parentheses, dot, double underscore, init double underscore, empty parentheses. Then we make the turtle visible with self dot, show turtle, empty parentheses. Next, we give it a shape with self dot shape, open parenthesis. Square in quotes, close parenthesis. This gives it a base square shape, which will stretch into a platform. We assign the input length to a class attribute with self.length equals length. This lets us reuse the value later if we need to adjust or compare the platform size. Now we scale the shape with self.shape size, open parenthesis, plat underscore shape underscore size, comma, self.length, close parenthesis. Here, plat shape size is the height of the platform and length is the width, which we passed in. Then we set the outline and fill colors. Self.pen color, open parenthesis, white in quotes, close parenthesis. Self.fill color, open parenthesis, saddle brown in quotes, close parenthesis. Finally, we position the platform using self.goto, open parenthesis, plat underscore x, comma, plat underscore y, close parenthesis. And one last thing. We set self.floor underscore num equals 0. This is an extra property we'll use later to track the floor number of each platform, so we can calculate things like score or speed. And that's it. We now have a platform class that creates a square turtle, stretches it into a rectangle, colors it, and places it on screen. Now that we've built our wall and platform classes, it's time to head over to the main game file, main.py, and put them to work. Let's start at the top of the file. Right below the import turtle line, we write import random. This brings in Python's random module, which we'll use to create platforms with random lengths and positions. Next, we import the classes we just created. Below the import from constants line, we write from renderer import wall, comma, platform. This gives us access to our wall and platform classes inside this file. Now let's scroll down to our main function, and right after we create the screen, we'll add a new section to create the class objects. Remember, a class is just a blueprint. To actually use it in our game, we need to create specific objects from it, like actual walls and platforms that appear on screen. So under the line that creates the screen, we'll add two parts, one for creating the walls and one for creating the platforms. Let's start with the walls. We write right underscore wall equals wall, open parenthesis, screen underscore width divided by 2, minus wall underscore pixel underscore size, close parenthesis. This passes in a single value, x, which is the horizontal center position of the right wall. Remember, the constructor of the wall class takes one argument, the x-coordinate, which determines where the wall will appear horizontally. Then, left underscore wall equals wall, open parenthesis, negative screen underscore width divided by 2, plus wall underscore pixel underscore size, close parenthesis. That places the left wall on the opposite side, again using an x value for its center position. We add a small offset from the screen borders using the wall's size, so the entire width of each wall stays visible on screen. Even though we're using the regular division symbol, we made sure the result is a whole number. That's important when working with pixel-based layouts, because fractions can cause misalignment or rendering glitches. Finally, we group both walls into a list. Walls equals open square bracket, right underscore wall, comma, left underscore wall, close square bracket. This keeps our code clean and lets us pass both walls around easily later. And that's it. We've placed both wall objects neatly on each side of the screen. Now let's create the floor, which is actually just the first platform in our game. We write floor equals platform, open parenthesis, 0, comma, ground underscore y, comma, floor underscore shape underscore length, close parenthesis. This creates a platform at the very bottom of the screen, with its center at x equals 0 and y set to ground y, that places it just above the bottom screen edge, centered horizontally, right where the player will land when the game starts. We also pass in floor shape length as the third parameter, which controls how wide this first platform will be. We calculated it to fit between the two walls, with a small margin on each side. Just like before, notice that platform is capitalized, because we're calling the class constructor to create an object. Then we write platforms equals open square bracket, floor, close the square bracket. This creates a list that holds our platform objects, starting with the floor as the first item. We'll use this list to store all platforms we generate going up the tower. Next, we move on to creating additional platforms that go upward. We use a loop. For I in range, open parenthesis, 30, close parenthesis, colon. This means we're going to create 30 platforms in total, spaced out vertically above the floor. Inside the loop, we start by choosing a random length for the platform. We write length equals random.randint, open parenthesis, 6, comma, 12, close parenthesis. This gives us a random number between 6 and 12, which determines how wide the platform will be. We'll use this value to set the shape size of the platform, so each one appears with a slightly different width. The reason we do this is to add variety to the game, so the player doesn't jump on platforms that are all the same size. Now we need to figure out how far left or right the platform can be placed so it doesn't go off screen. We write max underscore x equals open parenthesis, floor underscore pixel underscore length minus length times 20, close parenthesis divided by 2. Here's what's going on. First, we calculate how wide the platform will be in pixels by multiplying its length by 20. Then we subtract that from the full floor width, so we know how much total horizontal space is left. Finally, we divide by 2. To get the maximum distance the platform can be placed from the center while still fitting on the screen. This value, max underscore x, gives us the range within which we can safely place the platform horizontally without it being cut off or overflowing past the walls. Next, we calculate the horizontal position of the platform. We write plat underscore x equals random.randint, open parenthesis, negative int of max underscore x, comma, int of max underscore x, close parenthesis. This picks a random x position within the safe horizontal range we just calculated, so the platform appears somewhere between the walls without going off screen. In other words, we make sure the entire platform fits inside the playable area, no matter what random length it gets, and doesn't overlap the walls or extend beyond the screen. We use the int function here, just to make sure we're giving randint whole numbers, since it only works with integers. Then we calculate the vertical position using plat underscore y equals ground underscore y, plus, open parenthesis, I plus 1 close parenthesis, times, open parenthesis, player underscore pixel underscore size, plus plat underscore pixel underscore size, plus screen underscore margin, close parenthesis. This stacks the platforms upward with a bit of space between each one. We include the player size, platform size, and a margin to make sure there's enough room to jump comfortably. The variable I is the loop index, and it increases from 0 to 29 as we go through the loop. By multiplying this spacing by I plus 1, each new platform gets placed 1 unit higher than the last, creating a staircase of platforms climbing up the tower. Now we create the actual platform object. We write platform equals platform, open parenthesis, plat underscore x, comma, plat underscore y, comma, length, close parenthesis. This uses the position and width values we just calculated. Then, we set a floor number for this platform. Platform.floor underscore num equals I plus 1. This lets us track how high the player has climbed later. so we can increase the score as the game progresses. Finally, we add this platform to the list by writing platforms.append, open parenthesis, platform, close parenthesis. Next, at the bottom of the main function, where we call our game loop and pass it just the screen, we'll now add the walls and platforms lists as well. Right now, we don't actually need to pass them because they're already being drawn when we create the objects. But we're going to pass them anyway. So the game loop is ready to use them later for things like collision detection and scoring. So go ahead and add them both to the game loop call. Now, we also need to update the game loop function itself. So scroll up to its definition and add walls and platforms after the screen parameter. And don't forget, inside the onTimer call, we also need to pass walls and platforms again when we recall the loop. That's it. Go ahead and save your work and then run the game. You should see your walls on the sides and a staircase of platforms going up the tower. It's not interactive yet, but this is our first full layout on screen. With the level design in place, we've built the perfect foundation to start adding gameplay. This means everything is working, and our game layout is now fully on screen with walls on the sides and platforms stretching up the tower. Before we wrap up, let's take a quick look at what we've built. In this episode, we created all the visible elements of the level. We placed the sidewalls, built a list of platforms with random widths, and stacked them with clean spacing using pixel math. We also connected everything to the game loop, so we're ready to start interacting with these objects. In the next episode, we'll add the player character and set up basic movement. You'll learn how to control the player with the keyboard, so we can finally start moving around the screen. It's where the gameplay begins, so don't miss it. If you found this helpful, a like and subscribe would really help support the channel. And make sure you don't miss what's coming next. I'm the Wannabe Coder. Thanks for watching, and I'll see you in the next episode.